A-level maths students, take note. The examiner said that this proof question proved to be challenging for many students, and very few were able to gain more than half of the marks available. Let's take a look at it so that you can be prepared if a similar one comes up in your exam. Notice here it says, in this question you must show detailed reasoning. So we've got to set out every step of our working clearly to pick up all of the marks. It says, given that x and y are positive numbers, such that this condition holds, prove that y is greater than x for 4 marks. Notice that what we've got on the left-hand side here can be expanded really efficiently using the binomial theorem. Yes, you could expand triple brackets, but why not use the binomial theorem? Let me show you a really quick and cool way to set up the binomial theorem that's going to cut down on so many of those little errors that you might normally make. So here, we've got a power of 3. So all of these parts have 3 choose something. And notice that it's starting with 3 choose 0, then 1, 2, and 3. Notice that the powers of y do the same thing, 0, 1, 2, and 3. But the powers of x go the other way. They start with 3 and end in 0, 3, 2, 1, 0. Notice that each pair of powers here, 3 and 0, if you add them together, you get this number, you get the power here. Notice 2 and 1, add them together, you get the power of 3, and so on. That's a good little check that you haven't made a mistake here. You could work out these binomial coefficients here using your calculator, but maybe it's quicker to use Pascal's triangle. Here's the first row of Pascal's triangle, and the second, and the third row. We need the third row because the power is 3. So we have the coefficients 1, 3, 3, and back to 1 again. Notice it's symmetrical. So we can replace those in here, and note that anything to the power of 0 is just 1. And when we square negative y, we get just y squared. If we collect these together and write them nicely, we end up with this expression here. However you do that, whether you use the binomial or not, that gives you your first method mark. So we're starting with this. We're told that x and y are positive numbers that satisfy this condition. So that's our starting point. We need to show where this comes from. So what can we do with this? Well, we can replace it with the expanded form here. Next, we can subtract x cubed and add y cubed to get 0 here. Notice that these effectively cancel out and these cancel out. Next, we can factorize. This and this have something in common. A 3, an x, and a y. That will leave us with a minus x plus y inside the brackets here. Now it's tempting at this stage just to divide by this, but we need to justify that. Remember, it said in the question, in this question you must show detailed reasoning. So we need to explain why it's okay for us to divide by, in particular, by x, y. Because you know that whenever you multiply or divide an inequality by a negative, you have to flip around the inequality sign. How do we know that we don't have to flip around the inequality sign? Well, we don't because x and y are both positive. Neither of them are negative. So we need to make that point to score the final mark. As both x and y are both positive, then we can divide by this term without having to flip around the inequality sign. So we're left with this is greater than 0. And all we need to do is to add x to both sides, and we end up with the result that we wanted. Part B says, using a counterexample, show that the result in part A is not true for all real numbers. So in part A we showed that it is true if x and y are positive numbers. But now we need to show that sometimes it's not true. So it would be silly to try examples where x and y are both positive, because we've proved in part A that it always works if they are both positive. But here, we really need to consider as a clue that x or y might be negative. How about if x equals 3 and y is negative 1? Then the left-hand side here, let's work out what that would be. That would be 3 minus minus 1 all cubed. That's 4 cubed, that's 64. The right-hand side here, x cubed minus y cubed, that would be 3 cubed minus minus 1 cubed, 27 minus minus 1, that would be 28. So holds because x minus y all cubed is 64 and x cubed minus y cubed is 28, and 64 is greater than 28. So this condition does hold. But does this hold? Is y greater than x? Well, y was minus 1 and x was 3, and minus 1 is not greater than 3. Notice this symbol means not greater. So therefore y is not greater than x. So the result is not true for all real numbers. A counterexample is simply a single example that shows that a result isn't always true. So that's it. We've just given one example, this pair, x and y, that doesn't work. That's all we need. How do you think that you would have done in that question? Would you have scored full marks? Let me know in the comments.